A cellular network or mobile network is a telecommunications network where the link to and from end nodes is wireless and the network is distributed over land areas called cells, each served by at least one fixed location transceiver, typically 3 cell sites or base transceiver stations. These base stations provide the cell with the network coverage which can be used for transmission of voice, data, and other types of content. A cell typically uses a different set of frequencies from neighboring cells, to avoid interference and provide guaranteed service quality within each cell. When joined together, these cells provide radio coverage over a wide geographic area. This enables numerous portable transceivers, example mobile phones, tablets and laptops equipped with mobile broadband modems, pagers, etc., to communicate with each other and with fixed transceivers and telephones anywhere in the network, via base stations, even if some of the transceivers are moving through more than one cell during transmission. Cellular networks offer a number of desirable features. More capacity than a single large transmitter, since the same frequency can be used for multiple links as long as they are in different cells. Mobile devices use less power than with a single transmitter or satellite since the cell towers are closer. Larger coverage area than a single terrestrial transmitter, since additional cell towers can be added indefinitely and are not limited by the horizon. Capability of utilizing higher frequency signals, and thus more available bandwidth/faster data rates, that are not able to propagate at long distances. With data compression and multiplexing, several video, including digital video, and audio channels may travel through a higher frequency signal on a single wideband carrier. Major telecommunications providers have deployed voice and data cellular networks over most of the inhabited land area of Earth. This allows mobile phones and mobile computing devices to be connected to the public switched telephone network and public internet access. Private cellular networks can be used for research or for large organizations and fleets, such as dispatch for local public safety agencies or a taxicab company. The first commercial cellular network, the 1G generation, was launched in Japan by Nippon Telegraph and Telephone, NTT, in 1979, initially in the metropolitan area of Tokyo. Within 5 years, the NTT network had been expanded to cover the whole population of Japan and became the first nationwide 1G network. It was an analog wireless network. The Bell system had developed cellular technology since 1947, and had cellular networks in operation in Chicago and Dallas prior to 1979, but commercial service was delayed by the breakup of the Bell system, with cellular assets transferred to the regional Bell operating companies. The wireless revolution began in the early 1990s, leading to the transition from analog to digital networks. This was enabled by advances in MOSFET technology. The MOSFET, originally invented by Mohammed M. Adila and Awon Kong at Bell Labs in 1959, was adapted for cellular networks by the early 1990s, with the wide adoption of power MOSFET, LDMOS, RF amplifier, and RF-CMOS, RF circuit, devices leading to the development and proliferation of digital wireless mobile networks. The first commercial digital cellular network, the 2G generation, was launched in 1991. This sparked competition in the sector as the new operators challenged the incumbent 1G analog network operators. Practically every cellular system has some kind of broadcast mechanism. This can be used directly for distributing information to multiple mobiles. Commonly, for example in mobile telephony systems, the most important use of broadcast information is to set up channels for one-to-one communication between the mobile transceiver and the base station. This is called paging. The 3 different paging procedures generally adopted are sequential, parallel, and selective paging. The details of the process of paging vary somewhat from network to network, but normally we know a limited number of cells where the phone is located. This group of cells is called a location area in the GSM or UMTS system, or routing area if a data packet session is involved. In LTE, cells are grouped into tracking areas. Paging takes place by sending the broadcast message to all of those cells. Paging messages can be used for information transfer. This happens in pagers, in CDMA systems for sending SMS messages, and in the UMTS system where it allows for low downlink latency in packet-based connections. In a primitive taxi system, when the taxi moved away from a first tower and closer to a second tower, the taxi driver manually switched from one frequency to another as needed. If communication was interrupted due to a loss of a signal, the taxi driver asked the base station operator to repeat the message on a different frequency. In a cellular system, as the distributed mobile transceivers move from cell to cell during an ongoing continuous communication, switching from one cell frequency to a different cell frequency is done electronically without interruption and without a base station operator or manual switching. This is called the handover or handoff. Typically, a new channel is automatically selected for the mobile unit on the new base station which will serve it. The mobile unit then automatically switches from the current channel to the new channel and communication continues. The exact details of the mobile system's move from one base station to the other vary considerably from system to system. See the example below for how a mobile phone network manages handover. The most common example of a cellular network is a mobile phone, cell phone, network. A mobile phone is a portable telephone which receives or makes calls through a cell site, base station, or transmitting tower. Radio waves are used to transfer signals to and from the cell phone. Modern mobile phone networks use cells because radio frequencies are a limited, shared resource. Cell sites and handsets change frequency under computer control and use low-power transmitters so that the usually limited number of radio frequencies can be simultaneously used by many callers with less interference. A cellular network is used by the mobile phone operator to achieve both coverage and capacity for their subscribers. Large geographic areas are split into smaller cells to avoid line-of-sight signal loss and to support a large number of active phones in that area. All of the cell sites are connected to telephone exchanges, or switches, which in turn connect to the public telephone network. In cities, each cell site may have a range of up to approximately 1 mile, 0.80 kilometers, while in rural areas, the range could be as much as 5 miles, 8.0 kilometers. It is possible that in clear open areas, a user may receive signals from a cell site 25 miles, 40 kilometers, away. In rural areas with low band coverage and tall towers, basic voice and messaging service may reach 50 miles, 80 kilometers, with limitations on bandwidth and number of simultaneous calls. Since almost all mobile phones use cellular technology, including GSM, CDMA, and AMPS, analog, the term cell phone is in some regions, notably the US, used interchangeably with mobile phone. However, satellite phones are mobile phones that do not communicate directly with a ground-based cellular tower but may do so indirectly by way of a satellite. There are a number of different digital cellular technologies, including Global System for Mobile Communications, GSM, General Packet Radio Service, GPRS, CDMA1, CDMA2000, Evolution Data Optimized, EVDO, Enhanced Data Rates for GSM Evolution, EDGE, Universal Mobile Telecommunications System, UMTS, Digital Enhanced Cordless Telecommunications, DECT, Digital AMPS, IS-136/TDMA, and Integrated Digital Enhanced Network, IDEN. The transition from existing analog to the digital standard followed a very different path in Europe and the US. As a consequence, multiple digital standards surfaced in the US, while Europe and many countries converged towards the GSM standard. A simple view of the cellular mobile radio network consists of the following. A network of radio base stations forming the base station subsystem. The core circuit switched network for handling voice calls and text. A packet switched network for handling mobile data. The public switched telephone network to connect subscribers to the wider telephony network. This network is the foundation of the GSM system network. There are many functions that are performed by this network in order to make sure customers get the desired service, including mobility management, registration, call setup, and handover. Any phone connects to the network via an RBS, radio base station, at a corner of the corresponding cell, which in turn connects to the mobile switching center, MSC. The MSC provides a connection to the public switched telephone network, PSTN. The link from a phone to the RBS is called an uplink, while the other way is termed downlink. Radio channels effectively use the transmission medium through the use of the following multiplexing and access schemes: frequency division multiple access, FDMA, time division multiple access, TDMA, code division multiple access, CDMA, and space division multiple access, SDMA. Small cells, which have a smaller coverage area than base stations, are categorized as follows: microcell less than 2 km, picocell less than 200 meters, femtocell around 10 meters, attocell 1 to 4 meters. As the phone user moves from one cell area to another cell while a call is in progress, the mobile station will search for a new channel to attach to in order not to drop the call. Once a new channel is found, the network will command the mobile unit to switch to the new channel and at the same time switch the call onto the new channel. With CDMA, multiple CDMA handsets share a specific radio channel. The signals are separated by using a pseudo-noise code, PN code, that is specific to each phone. As the user moves from one cell to another, the handset sets up radio links with multiple cell sites, or sectors of the same site, simultaneously. This is known as soft handoff because, unlike with traditional cellular technology, there is no one defined point where the phone switches to the new cell. In IS-95 interfrequency handovers and older analog systems such as NMT, it will typically be impossible to test the target channel directly while communicating. In this case, other techniques have to be used, such as pilot beacons in IS-95. This means that there is almost always a brief break in the communication while searching for the new channel, followed by the risk of an unexpected return to the old channel. If there is no ongoing communication or the communication can be interrupted, it is possible for the mobile unit to spontaneously move from one cell to another and then notify the base station with the strongest signal. The effect of frequency on cell coverage means that different frequencies serve better for different uses. Low frequencies, such as 450 MHz NMT, serve very well for countryside coverage. GSM 900 MHz, is suitable for light urban coverage. GSM 1800, 1.8 GHz, starts to be limited by structural walls. UMTS, at 2.1 GHz, is quite similar in coverage to GSM 1800. Higher frequencies are a disadvantage when it comes to coverage, but it is a decided advantage when it comes to capacity. Picocells, covering e.g. one floor of a building, become possible, and the same frequency can be used for cells which are practically neighbors. Cell service area may also vary due to interference from transmitting systems, both within and around that cell. This is true especially in CDMA-based systems. The receiver requires a certain signal-to-noise ratio, and the transmitter should not send with too high transmission power in view to not cause interference with other transmitters. As the receiver moves away from the transmitter, the power received decreases, so the power control algorithm of the transmitter increases the power it transmits to restore the level of received power. As the interference, noise, rises above the received power from the transmitter, and the power of the transmitter cannot be increased anymore, the signal becomes corrupted and eventually unusable. In CDMA-based systems, the effect of interference from other mobile transmitters in the same cell on coverage area is very marked and has a special name, cell breathing. One can see examples of cell coverage by studying some of the coverage maps provided by real operators on their websites or by looking at independently crowdsourced maps such as OpenSignal or Cell Mapper. In certain cases they may mark the site of the transmitter, in others, it can be calculated by working out the point of strongest coverage. A cellular repeater is used to extend cell coverage into larger areas. They range from wideband repeaters for consumer use in homes and offices to smart or digital repeaters for industrial needs. Thank you for watching this video.